Dependent events. In this video, you will learn how to calculate the probability of dependent events. If you have any question on how to identify types of compound events, I suggest you watch these videos before continuing. If not, go ahead. Don't forget to subscribe, and if you have any question, feel free to ask or suggest anything. Dependent events are events for which the occurrence of one of the events does affect the occurrence of the other event. Let's see how it works. Example. Suppose a box contains 3 red and 2 green marbles. One marble is randomly chosen, its color is noted, and it's then put aside. A second marble is then randomly selected. What is the probability the first is red and the second is green? The events are dependent because there are 5 marbles when we choose the first marble. But when we put it aside, we change the number of marbles inside the bag. And there are 4 marbles inside the bag when we choose the second marble. Therefore, the result of the second event is affected by the result of the first event. The probability of first is red and second is green is 3/5 times 2/4. After simplifying, we get 1/10. The first fraction is the probability of the first marble is red. And the second fraction is the probability of the second marble is green, given that the first is red. It's always true that if A and B are dependent events and A occurs first, then the probability of A and B is probability of A times probability of B, given that A has occurred. This can be written as this notation is called conditional probability and is read the probability of event B given that event A has occurred. We can rewrite the formula above, and the conditional probability formula is in other words, event A has already happened. Now, what is the chance of event B? When we are dealing with dependent events, things can get a little confusing. So let's work out a few examples to make things clearer. Example. A pocket in a golf bag contains 6 white and 4 red golf balls. 2 of them are selected at random without replacement. Determine the probability of getting a red, then a white. You may have already noticed what those 2 words mean. Without replacement means the events are dependent. So take the formula for dependent events. We want the first is red and the second is white. The probability the first is red is 4/10. The probability the second is white, given that red has occurred, is 6/9. The probability is 27%. Example. A container has 4 purple and 3 blue ticked. 2 of them are selected at random without replacement. Determine the probability that both are purple. Take the formula for dependent events. We want the first is purple and the second is purple. The probability the first is purple is 4 over 7. The probability the second is purple given that purple has occurred is 3 over 6. The probability is 29%. Example. You have a fair die. What would be the probability of rolling a 5, given that you know you rolled an odd number? This is a given that problem, so we can use the conditional probability formula. The probability of 5 given that odd has occurred is probability of 5 and odd over probability of odd. Probability of 5 and odd is 1 over 6 because in a fair die we have one number 5. The probability of odd is 3 over 6 because we have 3 odd numbers. So the probability of 5 given that odd has occurred is 1 over 6 divided by 3 over 6. The probability is 1/3. We could approach this problem in another way. As we know that odd has occurred, we have only 3 possible outcomes: 1, 3, and 5. The number of possible outcomes is 3. The favorable outcome is 5. The number of favorable outcome is 1. So the probability of 5 given that odd has occurred is 1 over 3. Example. What is the probability that you have pulled the jack of clubs from a standard deck, given that you know you have pulled a face card? This is a given that problem, so we can use the conditional probability formula. The probability of jack of clubs and face card is 1 over 52, because in a standard deck of cards we have one jack of clubs. The probability of face card is 12 over 52, because in a standard deck of cards we have 12 face cards. The probability of jack of clubs given that a face card has occurred is 1 over 52 divided by 12 over 52. The probability is 1 over 12. We could approach this problem in another way. As we know that face card has occurred, we have 12 possible outcomes. The number of possible outcomes is 12. The favorable outcome is jack of clubs. The number of favorable outcome is 1. The probability of jack of clubs given that a face card has occurred is 1 over 12.